Hi all, here's another example of working with a function represented by a formula. So square roots can give a lot of trouble. I wanted to make sure I got them in here more than once. So this is going to be an example where we have to try and simplify a difference quotient involving a square root function. And we'll talk about graphing transformations, and we'll work on an inverse again so we can mention that one-to-one stuff. Okay, so first thing, the difference quotient. Here, let me slide my paper from behind so I don't ruin it. Okay, so if we want g of x plus h minus g of x over h, we should first take the x plus h and plug it into our function g. Our function g is going to take that x plus h and it is going to multiply it by 4. It is going to subtract 8. It will square root that and then multiply by a -1. We are then supposed to subtract function g of x, so it's going to be minus a negative root, end up being plus the square root of 4x minus 8 all over h. Okay, so there's my full setup, and I'm going to have to rewrite again to make my next step fit. So I'm going to go ahead and distribute a negative square root of 4x plus 4h minus 8 plus the square root of 4x minus 8 all over an h. And again, your goal when you're simplifying these things is to try and clean up the numerator to the point where you can factor an h out to cancel the bottom h. So our goal is that we can plug 0 in for h, which can't happen until this h is canceled. So just like before, when you have these square roots, the trick is to multiply by the conjugate. So we're going to take this exact same thing, and actually there's a couple ways to do it, but I don't want to mix you up too much. So we're going to take this exact same thing, and we're just going to switch this to a minus. It should also work if you just want to switch the first one to a plus and leave this one alone. Switching one of the signs should do it, but I'm just going to stick with the typical switch that middle sign. We can't just do that to the top. We have to do it to the bottom as well. Okay, so this is what we're doing. This makes a little bit more mess in the bottom. I'm fine with that. Temporarily, the top is going to look like a nightmare, but really nice things actually happen. So let's look at the top. Okay, so let's see if I can label some of this. So this has to get multiplied by this. So again, we're multiplying 2 terms by 2 terms, so there's 4. So this is going to be our first. The negative times a negative becomes a positive 1. So the negatives out in front are going to go away. When you multiply the square root by itself, the square root is also going to go away. So there's a 4x plus 4h minus 8. Because I can already tell it's not going to fit if I try and write this. I'm not going to actually write out all the steps here, but I am going to point it out. So the inside outside are really important. Here is the outside. So you're going to get a positive square root 4x plus 4h minus 8 multiplied by square root 4x minus 8. The negatives will wipe each other out. Not very helpful. The square roots don't wipe out. But then if you look at the inside, you're going to, so this was a positive square root times square root. For the inside pair, you're going to get a negative square root times square root. So here, even though I'm not writing it all out, we get this whole square root mess minus the exact same thing. That adds up to 0. So that part is actually completely gone. And then all that's left is last, which is this root times this root. And there's going to be a negative. So we'll have a negative square root 4x minus 8 times itself will just be 4x minus 8. Again, the grouping is really important. That root goes away, but those two have to stay grouped up so that you distribute the negative sign. And then on the bottom, I have h times negative root 4x plus 4h minus 8 minus the square root of 4x minus 8. Okay, so as we start to clean this up, I see that I'm going to have a 4x minus a 4x, and I'm also going to have a negative 8. This will become minus negative, so plus negative 8. So really, all that's going to be left over here is all the bottom stuff. And then on top, there's just a 4h. Which means we can cancel the h's. This was our big goal all along, was to try and cancel, divide out an h completely. So our answer here is going to be negative root 4x plus 4h minus 8 minus root 4x minus 8 in the bottom and a 4 in the top. There is some stuff you could do to extract a 4 out of these roots. I'm not worried about that part happening. I'm just worried about you being able to get through the rationalize the numerator algebra. So there's another example. Hopefully this is starting to settle in. I think I gave you fairly simple root functions to work with, so it wouldn't be too terrible of a mess. Okay, I took that paper out. Where did I put it? So next part on this one, same function, is to review the graphing transformations. So I'm looking at a y equals the square root of 4x minus 8. Oh, and there's a negative out in front. Okay, so I'm thinking of starting with a basic square root graph, which hopefully we all know looks like this. And then I see a flip upside down. That negative out in front of the root will flip the whole thing upside down, so I can kind of keep track a little bit in my head here. So it's going to be an upside down version of that. Multiplying x by 4 is a pretty decent horizontal compression, which in this case might make it just appear to be taller, but it's really that this whole thing has scrunched back, so this point ends up way closer to the x-axis. And then this minus 8 appears to be a shift to the right by 8, but it is not. Once again, you have to be careful. So you have two choices. The Maya way to do this is to always do your shifting last. But in order to stick with that, you would have to factor out whenever you have a coefficient of x. So if x has a horizontal shift combined with any other horizontal transformation, you'll have to do this quick factor step and say, actually, I'm only going to shift right by 2. So I would expect to end up with something sort of roughly shaped like that. So that's what I'm expecting to end up with. Let's follow at least a couple of points. Let's follow 0, 0. It's really important to know where that n lands. We're predicting it's negative 2, 0. And then let's follow 4, 2. Okay, so 0, 0. When we do the flip, doesn't go anywhere. When we do the compression, still doesn't go anywhere. When we do the shift, oh, look at me shifting the wrong way in my picture. We're shifting to the right 2, so it lands at 2, 0. So ignore that first one. Okay, so the end of this thing is going to be at 2, 0. If we then follow 4, 2, we flip, it ends up at 4, negative 2. We compress, it ends up at 1, negative 2. So we're dividing all of our x's by 4, scrunching everything towards the y-axis. And then we shift right 2, and it ends up at 3, negative 2. Debating if I want to follow one more. I kind of want to follow one more point. We'll sneak it up here. What will I do? Let's do, since I know I have to divide by 4, let's do 16, 4. That's another point on the basic square root function. So when we flip, it goes to 16, negative 4. And then horizontal compression, we'll put it at 4, negative 4. Divide your x by 4. And then right 2 puts it at 6, negative 4. 6, negative 4. Okay, so that's starting to get me a pretty good picture. So I had my prediction, my second prediction, where I shifted the right direction. So I know that that's kind of the shape I'm expecting. And then I know a couple of these points spot on. 6. These 3 points I know exactly. So there is graph by using transformations for a square root function. Okay, and then last part, this one's not nearly so much of a beast as the last one. Let's find G inverse, and then we'll sketch its graph with G so that we can talk about this whole one-to-one business again. Okay, so if I want to find G inverse, again, my function here is y equals negative square root of 4x minus 8. So we're going to start with x equals negative square root of 4y minus 8. And we want to solve for y. So we only have one y on one side of the equations. This becomes a reverse order of operations sort of thing. So if you only have one of your variable, it's just peel off everything attached by reversing order of operations. So if I plugged in a y, the first thing I would do is multiply by 4, then subtract 8, then square root, then multiply by -1, which means to solve, the first thing I should do is get rid of the multiplication by -1. So multiply or divide both sides by -1. Okay, the next thing I need to get rid of is the square root. So let's go ahead and square both sides. There's no reason to leave the negative there. If you take a negative x and you square it, you're getting negative x times negative x. And those two negatives will wipe each other out, and the x should still be squared. So whether it's negative or not, that should be good for us. Square root is gone. Next, we need to get rid of the -8. So we're going to add 8 to both sides. And then divide by 4. So we have x squared plus 8 over 4 equals y. So we could say that G inverse, I'm going to go ahead and split that up. So 1/4 x squared divided by 4 is 1/4 x squared plus 8 divided by 4, which is 2. Okay, so in terms of adding this back to my graph, let me just think about this for a second. I have an x squared function, and I need to do a vertical compression, which is going to make it really kind of shallow looking. And then I need to shift it up 2. So 1, 2. So I'm going to get this sort of shape. Here's my trouble. If I look back up at that square root function I started with, to get a graph of its inverse, I would take it and I would flip it over y equals x. So I would take every point and I would say, okay, if this point is 2, 0, then the inverse should go through 0, 2, which actually seems okay with this graph, so I'm not so bad with that. If this one goes through 3, -2, this one should go through -2, 3. If this one goes through 6, -4, its inverse should go through -4, 6. So I'm getting part of this graph, but not all of it. And again, that's not actually a coincidence. You can never have a whole parabola. Your function and its inverse both have to be functions, pass the vertical line test, and one-to-one, pass the horizontal line test. So we have to choose either the left or the right half of our parabola, and the way we do it is from the pictures. So again, an easy way to do this is just to say, on this function, I can see that my y's are always less than or equal to 0, which means down here on the inverse, my x's have to be less than or equal to 0. Always domain and range switch, x and y switch, so domain and range switch. So we want to get rid of this. So what we're getting is half of a parabola. Looks like that. Okay, I think that's it for this one. Thanks for watching.